Dan Perry here, and this is part 30 of our TCP/IP Basics Ethernet Frames. In this video, we're going to look at the Ethernet frame and talk about what the frame purpose is. Ethernet is the most used type of LAN, at least wired, with 99% or more of the wired LAN connections. It was developed in the 1970s by Bob Metcalf at Xerox. Now, there are four main types of Ethernet frames that are used. Primarily today, only one of them is widely used. Now, the Ethernet 802.3 frame type is what the IEEE has standardized on, but the Ethernet 2 is what really is dominating the market. We're going to look at the 802.3 frame type as our example. The others are very, very similar. Very slight differences in the frame header. So by looking at the 802.11 or 802.3 frame type, we'll see what the how all the frames basically look and operate. Now, here's just a diagram of the frame type. You have a preamble, we'll talk about, then a start of frame delimiter, your addressing, you have an optional tag, then you have your frame type, payloads, at the end of frame check sequence. There's a gap afterwards on it. So frame types basically will go anywhere from basically 64 octets. Bigger if we include the preamble and start a frame delimiter, up to about 1542, again, if we include those things that we're going to talk about not being truly part of the frame. The preamble and start a frame delimiter, basically there to alert the network card that the frame is on the line, that the frame is coming, so it has time to get ready for it. Essentially wakes up the NIC, says, hey, I've got something coming for you. The start of frame delimiter lets the NIC know when the frame actually starts. So you've got a pattern of ones and zeros coming on in that preamble. Then you hit the start of frame delimiter that has patterns of ones and zeros, but then switches to 2 ones, and that alerts or tells that network card, okay, the frame's starting. It's usually not considered actually part of the frame. Now, the MAC address is a 6-byte address. It is a physical address that's basically burned into your network card. Your MAC address indicates or tells what the network card's physical address is. It's used for getting traffic to a particular device on your network. It is unique. Now, the first 3 bytes of the MAC address indicates the manufacturer, and the last 3 the particular device from that manufacturer. We put in that frame, we put the destination first so the NIC can quickly determine whether or not the frame is met for it, and if it's not, just ignore it. It can be also speed up switching, because as the frame's coming into a switch can look at that destination address and begin decoding and determining what to do with that frame before the entire frame is in the switch. Optionally, you may have an 802.1 Q tag, which is a tag that is used for creating VLANs or virtual LANs. That's the topic of a whole nother series of videos, but virtual LANs essentially allow us to take our network and separate it or isolate parts of it on the same set of wires. The frame type field indicates the type of frame. It is, for example, 802.3 or an Ethernet 2, an Ethernet snap, or any of the other many frame types out there, most of which are either not used or very rarely used. The payload That's the data. That is the information that you're transmitting to the other end. Now, this does include the encapsulation of the network and transport layers that we've talked about in other videos. The minimum is 42 bytes, and that ensures that all frames will be at least 64 bytes long. The maximum is 1500 bytes, meaning that a frame it can be 1518 bytes in total size. After the data, we have a 4-byte error checking, and this uses something called a cyclic redundancy check. Say that 3 times fast. And it is used to detect errors. The CRC essentially can tell whether or not the frame came in correctly. It cannot tell where the error was in the frame, just that the frame was received correctly. Afterwards, there is an interframe gap or an idle time before you can transmit another frame. It is not part of the frame itself. It's just basically taking a breath before you start the next frame. That interframe gap is 12 bytes in size. Of course, if you transmit and you don't need to transmit anything else, you would not put in, or you would have a longer gap. But if you do have to transmit multiple frames, you do have to put 12 bytes of idle between them, and that again allows time for the network card to see that the next frame's coming. Now, the next time we're going to begin looking at Wireshark. And Wireshark is a tool we'll use to start doing our network analysis.